We also have Richard Flynn, chairman of Iowa at Irish On-Site Wastewater Association, and is also the vice president of Cape Vice President. And we also have Dendra Best, she's the executive director from the Iris Water. Dendra will be giving a detailed introduction for the board members. And without further ado, let's welcome our speakers to the virtual stage.
Thank you. We'd certainly like to thank University of Hawaii for this opportunity. It's our chance to introduce our organization, WasteWater Education 501c3. We're a registered US nonprofit. And the reason that we're happy to be talking to you is that I actually moved to the Big Island several years ago. I live in Pahoa, and people often ask me, how can you work from Pahoa when your audience is international? And we have surprisingly a much better internet connection here than I had back home in Michigan. So we tell people wherever we are, that's where we can work. We're about to go into our 21st year of operation, and I've had the great pleasure of being part of this journey from actually the very first organizational meeting. It was one of these occasions where somebody said, does anybody here have nonprofit experience? And I foolishly put my hand up, and I've been here ever since. So over the past 21 years, we've really seen our organization grow. Originally, we were funded by 2 Joyce Foundation grants, and at the time, the emphasis was on Great Lakes Basin advocacy. We've gone from that to being a rapidly expanding international education service provider. The original Joyce Foundation grant mission hasn't really changed, which I think is kind of sad in some ways, because it was seeking to expand the awareness and the acceptance of decentralized water and wastewater treatment as part of aquifer and groundwater and watershed protection. At the time, some of the biggest systems that were being proposed throughout the Great Lakes were really enormous water diversions or water withdrawals. You may recall there was a really weird proposal at one point to extract water from Lake Michigan and ship it down to the desert Southwest, which thankfully, after the Great Lakes Compact and other international law, never actually took place. But when we started doing education, we heard loud and clear from a whole bunch of wastewater service providers and municipalities that having a physical location to have to go to do required training, or even just to learn something new, was taking a day or even 2, 3 days out of their schedule. And when you work for yourself, you don't have the resources to do, you can't shut your business down completely for those days. You're losing income. So looking back, it's quite amazing that by 2006, we were one of the first agencies to do live online virtual training. Now, training online via the web, or particularly now using mobile devices, is a whole different ballgame than if you are doing a presentation in a physical conference room setting. You know, adults learn differently. Particularly in these times, they need constant engagement. They need to feel they're respected and that they're part of a conversation rather than just being shown PowerPoints and lectured. So we always caution our presenters that come and do classes for us. If you're a terrible speaker in person, then you will die the death online in 30 seconds. So I'm hoping that isn't the case today. So technology really has changed forever the way we document, the way we research, the way we consume education and information. And our organization, WasteWater Education, is continually changing as well. There's no reason, and there really is no excuse not to openly share professional, operational, collective experience and knowledge. Our strength, I think, is our ability to quickly create and to quickly respond to requests for help. Our board, who you're going to be introduced to here in a minute, they're all active members of their own particular water resource profession. They all have extensive networks, and they're really happy to respond to requests, send an email on your behalf, make a phone call. The strength of our organization, I think, lies in the broad depth of our professional experience, our knowledge, and our generosity and our willingness to share that access. We are an organization founded on partnerships. I do invite you to go to our website and look up the rest of our board and our advisory board members. We often tell people when we're working on a project, we may not always be the lead dog. We don't mind not being the lead dog, but we're really damn good at being part of the team or putting the rest of the team together. We don't believe there's any place for ego in the water professions because, frankly, the stakes are just too high. There is no one answer to every situation. The one size fits all probably was never really the case, and it certainly isn't now. Anyone who is concerned about water resources will share how someone else has addressed a similar concern. We're happy to share what's worked and perhaps more importantly, what hasn't worked. We learn as much from other people's experience and mistakes as we do from ours. At one point, I know we were part of the fail forward process, which is share what you did that didn't work, and you could prevent someone else from wasting all that time, money, and effort as they go forward. And so now I'd like to introduce you to our board, and we're going to start with our current board chair, Ben Keel, and he's going to talk about why we're involved in our proposed initiatives for Hawaii, and also about the upcoming International Water Association session, specifically targeting developing nations and island nations in Australia. And from there, we will hand off, Ben, if you would, to Oliver, and Oliver to Leslie, and Leslie to Richard. And I will put a couple of links into the chat window for you. So take it away, Ben.
Hello from Australia, where it's already Saturday. Thank you very much for taking your time and coming into the webinar today. My part of Australia is here. Basically, I'm located in the Florida of Australia, which many people who know my personality would associate me with Floridans anyway. But Australia being a continent nation, we're very similar in size to the lower 48 in the US, but we've got a vast variety of different climatic zones. I'm in the wet tropics, and the Great Barrier Reef runs along through this area. So I'm also on the Pacific Ocean, the other side to where you guys are at the moment, but surrounded by coral reefs and tropical climates. Now, my crew absolutely loves working out on the Great Barrier Reef and the island communities out there. So the types of technologies that we work with, we've got options which are specifically designed for tropical islands and have been working on tropical islands for decades. And yeah, the type of technologies that we get to use in the more temperate zones or the desert zones here in Australia, you just can't cut and paste them into an island situation. We're very big on making sure that we've got fit for purpose technologies as we travel through. So I actually grew up on an island. My family owned an island where on the Great Barrier Reef was reasonable size. We're able to run 1,000 head of cattle. But because of that, I'm fully aware that doing work on islands is much more expensive than doing things on the mainland. You've got a lot of double handling on freight. You've got barges and air freight of things coming through. It's difficult getting people onto the island. You've got your skill shortages. So people on the mainland are complaining about skill shortages. People on islands, it's that much worse. And you've got different conditions between islands, right? A volcanic atoll is very different to a sand island. So you've got to make sure your technologies are fit for purpose. So the northern part of Australia and the Great Barrier Reef is very similar to the island situations that you've got there in Hawaii. And we've got many issues about protecting the reef. So where the big campaigns are about reef protection around Hawaii, we've got them here in Australia as well. And our First Nation communities are very strong in the island, particularly in tropical Australia. That's also true in Hawaii. So you can see here, we've got reef guardian schools, reef guardian councils, reef guardian fishers. There's a really big push on in Australia as far as protecting the Great Barrier Reef, but also the island communities and the fresh water which is present on those islands, including the groundwater underneath the islands, the freshwater lens. So there's a strong focus on making sure that there's sustainable water treatment, wastewater treatment, and water recycling. And to make it sustainable in the long term, you've got to get the whole community involved. So one of the technological techniques that we use is a contained evapotranspiration trench. It's marketed as the Rhizopod system, first used in 1998 in tropical Australia. And basically we do use this system in environmentally sensitive areas where we're trying to protect the groundwater, or we're trying to protect reefs or nearby environmentally sensitive areas. So it has a pre-treatment system such as a septic tank or a package treatment plant. The majority of them are configured as no release. So you'll have your septic tank or wastewater treatment system there, goes off into an aerated balance tank, pumped through a series of pods where you grow plants. And in tropical conditions, we quite often grow bamboo. And the reason why we like picking bamboo is that a mature clump of bamboo will use around 300 gallons of water a day. And using the Australian expression, you can't kill it with 3 bushfires and 10 litres of herbicide, right? It's so close to being a weed that it's very hard to kill. So you're chasing something that uses a lot of water and is environmentally resistant. Now we can do a plastic pod like this one or a concrete pod. And the whole idea is you keep your wastewater contained. It's not able to leach out into the environment. And you can put these on solid rock. So if you've got a property which is a lava field, you can actually put the concrete versions of these up on the surface. And this particular site here, it's right on the coast. The Great Barrier Reef is only 150 feet away from where this site is. It's using around 5,000 gallons a day. This is an RV park at a coastal community. And the bamboo, which is growing through there, none of it's being released. It's not going into the freshwater lens underneath the site. It's not going out into the reef, which is just nearby. It's all being reused in a non-release manner. Another thing that we try and do is use volcanic rocks. So Hawaii is an island full of volcanic rocks, full of zeolite and scoria. My PhD, if I ever hand it in, and it is over a decade later, and makes my supervisor cry, is all about using zeolites and scoria to be able to treat on-site and decentralized wastewater. So this is cation exchanging contaminants such as ammonia out of the water, and it will actually absorb things like phosphorus. So where you've got your brown water problems around Hawaii at the moment from all the cesspools discharging into the lava tubes, that volcanic rock can actually be turned into a filter media and be able to treat the water. And part of me is actually thinking that part of the issue might have been these lava tubes have been used to dispose of the water from the cesspools for so long that the cation exchange capacity of the volcanic rock directly in contact with the wastewater in the lava tubes has become exhausted. This cation exchange capacity doesn't last forever. It can last for years, it can last for decades, but it won't last forever until the ion exchange media is regenerated. So I think part of the issue maybe with the cesspools in Hawaii is that those ion exchange capacity of the lava tubes has been exhausted. But for economic sustainability, being able to harvest fresh volcanic rock, zeolite and scoria, and putting them into the treatment systems would be a fantastic way of using a local resource in on-site wastewater and be able to keep the costs down. So, and each volcanic rock makes its own. So each volcano produces a different cation selectivity. So where we're trialing different media through here, some of them are very good at taking ammonia out. Some are more focused on taking sodium out or calcium or potassium. Each volcano basically made its own. So part of a university trial that could occur with what we're looking at here is having a look at the cation selectivity preferences of the local volcanic rock and selecting those which are most suitable for on-site wastewater treatment. So you can make big sand and zeolite and scoria filter media. So these ones here are being used for a winery and a tourist facility, like a wedding facility. So it's much bigger than what you'd put in for a domestic situation, but you can have a look at Leslie's background, and she's got a very similar type of mound system, which is constructed in Canada there at the moment. We've done these types of things on a variety of developments. So this is the, once again, the Pacific Ocean out there and the Great Barrier Reef, sorry. And yeah, we've put in these types of technologies using zeolite to treat the water on these type of developments. You can see there that it's a high-end type of development. They're really selling the view. The sewage treatment plant, unfortunately, is on the other side of the hill and doesn't get this view out through there. But it's, yeah, very handy. Now, you can't get everything out of your passive systems. If you're looking to remove certain colors and things, you can use different techniques such as ozone. So this has got tannins in it. So there's and tannins you can get from peat or certain types of trees, contaminated groundwater. Ozone's very good at oxidizing those types of things out and improving the water color. So while I've mainly been talking about passive and low input techniques, there are more advanced treatment techniques, technological solutions that will remove certain things. Australia is full of interesting wildlife as well. So some of these sites, it's just a giant earthworm. That's a 4-inch pipe or a 100 mil pipe. So the spiders can get quite big in Australia, which is always fun. And we do have a lot of fun fishing in the Great Barrier Reef. And this is one of the reasons why we're going out of our way to protect it. So, conclusion. Living on an island, I'm sure you'll agree with me that cut and paste solutions from the mainland don't always work in an island community. And if you're putting something on an island, you want it to be robust and reliable. You don't want it breaking down every other week. It's that much harder to get the proper maintenance. Using materials available on the island and using local manufacturers is essential, as well as training local people in designs, construction, and maintenance. If you can't get that support there locally, in 2 years' time, you'll come back and your treatment chain will have fallen over due to lack of maintenance. And I'm a big believer that systems must be economically sustainable to be environmentally sustainable. You've got to have your maintenance budget also included in your treatment chain right from the design, so that you know that if you come back in 5 years' time, 10 years' time, that this is working. So I've got to stop my share here, and Denver's going to put up a slide for our International Water Association conference, which we've got at the end of the month, beginning of next month. So we've got a webinar. So we've got people from all over the world coming in and being part of the webinar. And there's also a conference on at Murdoch University, which is the other side of the continent from where I'm speaking to you from at the moment. But we're basically trying to promote the sharing of ideas as far as on-site and decentralized wastewater treatment, particularly in island communities and developing nations. So we think that there should be an awful lot more networking and ideas sharing in this particular space. And it would be absolutely fantastic if you could register for the webinar and keep an eye out on for the conference. Thank you very much. And hopefully I didn't crash and burn like Dendra often tells me that I do.
Okay. No, you didn't, and thank you. Let's hand off now to our board vice chair for this coming year. Well, halfway through now already. Oliver Greaveson. Oliver, why don't you go ahead and introduce yourself?
Thank you, Dendra. My name's Oliver Greaveson. I'm, as said, I work for the very large engineering consultancy Atkins Realis, where I'm an associate director and I specialise in wastewater monitoring. I'm also a professor in digital water at the University of Exeter here in the UK, which are very famous for sort of looking at hydroinformatics and looking at the problems, what we can use with data and monitoring to highlight some of the problems various, not just islands, various communities will have. So you may or may not be aware, in the UK, we've probably shot ourselves in the foot with monitoring over the past few years. There's quite a large sewage scandal going on in the UK, and all of that really came around with monitoring. So before, I'd say about 6 or 7 years ago, we didn't really monitor our wastewater network. We had very little monitoring. We had some monitoring at our wastewater treatment facilities, just mainly for control purposes, very little for regulatory purposes. Then there was a government direction saying all of our overflows to the environment are going to get monitored. So about what we're talking about 8 years ago, the program of monitoring started, and it's relatively cheap stuff. They're level monitors, they're sitting in the overflows, and it will basically tell the regulator when an overflow overflows to the environment from the sewer network. And that went on. The monitors got installed 2 or 3 years later. The data started getting reported to the regulator, and then everyone, the sort of underlying scandal came out. And if you won't necessarily see the UK news, but I think the last set of some figures that came out was about 300,000 spills to the environment each year. What that doesn't tell the full picture of what's going on, because that uses a method of counting of storms that the regulator does. So if an overflow goes to storm once in a 12-hour period or 1,000 times in a 12-hour period, that counts as one. So you can quite quickly see that monitoring of the environment and monitoring of the performance of the wastewater system uncovered quite a large scandal in the UK. And we monitor all our rivers, monitor the river quality, and it turns out nothing's in a very healthy space. So what I'm thinking I'm trying to say here is the lesson that we've learned in the UK is monitoring of the environment, monitoring how the wastewater system is behaving has been quite essential for us to know exactly what's going on. I'm going to take a step back now and say, when you monitor anything, the water system, the wastewater system, you've got to have a purpose for it. So a lot of the houses, and you'll all have water meters for your domestic water consumption. UK is heading towards smart water meters. If potable water is in short supply, it makes a lot of sense, because we know with smart water meters that roughly if somebody's got a smart water meter, it will decrease their water consumption naturally by 17%. The very knowledge of you being monitored means that you behave differently. Same with the wastewater system in the UK. We're actually monitoring what we're doing now, and there's a national scandal about what we're doing. But that monitoring's got to be right. Ben just mentioned in a small island environment. I worked in a small island environment for 5 years in the Falkland Islands. And if you've got an instrument, if you've got a monitor in place, again, Ben mentioned this, it's got to be maintained. Can you maintain it on the island? Is that cost of monitoring worth it? So when you monitor anything, be it your water system, your wastewater system, you've got to have a look and say, what's the value I'm going to get out of this? If there is a value, then great, monitor. And there's plenty of organizations out there, Dendra mentioned it right at the beginning, that are willing to help, willing to look at monitoring strategies, willing to look at what the value is for Hawaii on monitoring what aspects. So tourism, for example, absolutely essential in Hawaii. I know there's certain monitoring techniques going on with bathing water regulations that will tell somebody whether it's safe to bathe. And it's not the sort of take a sample and take it back to the lab testing. That's online monitoring now. It will monitor the water quality. You can put that up onto a display saying, this beach is safe to swim in today. Or actually, maybe not. It's working at a sort of level that, is it safe, is it not? What's the risk level of bathing in a particular area? So there's a lot that you can do with monitoring, but what brings value to the islands of Hawaii? What brings value to the communities? I'll give you an example. I dealt with the island of Guernsey about 5 or 6 years ago, and the guy who runs the water company on Guernsey, I met him at a conference and he said, Oliver, do you know anything about monitoring cesspits? I said, why do you ask? He said, we've got 200,000 tanker movements every single year for the 5,000 cesspits. Half our tanker drivers are going to cesspits and there's nothing to take out of them. So I said, well, yeah, it's quite simple. I can just put a little radar device in the top of the cesspit and we can beam that result any way you want. We can put a little MBIT backbone in the island. Most of the mobile phone companies will do it. And actually the benefit of that, if you've got the MBIT backbone, you can put smart water meters on it. You can put bin level monitors. You can put pretty much any monitor you like on there to help the local government to manage the community better. And he said, how's it so simple? I said, well, we're just monitoring the level. We can beam that to control. We can have a system in place and it works out about 50, 60 pounds a monitor. The little hockey puck size disc, just stick it to the top of the lid and it measures. Works on a IoT system into a centralized control. And we did the calculations. He was running 30 tankers, doing 200,000 trips a year. There was a potential once we did the calculations to cut that 200,000 down to about 20,000. Cut the tanker movements from 30 tankers at £1 million a tanker. So about £100,000 per tanker per year. So about 130,000 US dollars per tanker per year, to actually reduce that to 5 tankers per year. 5 tankers. So a massive decrease, a massive saving of the management, a massive saving on the road structure. So there's lots of potentials that can be done with monitoring, but it has to be value for the community. It has to give something to the community for the cost it's gonna have, and of course the cost of maintenance. Some of these devices, relatively low maintenance. Some of them, certainly the water quality monitors, very high maintenance. So whatever monitoring strategy that you put in place has got to be right for the community. And at that, I think I'll keep it short and sweet and hand over to Leslie.
Thanks, Oliver. I'm going to quickly share my screen. I only have like half a dozen slides, but hopefully they will be of interest. They'll at least remind me what I intended to say, if nothing else. So I guess we won't start at the conclusions. We'll start at the beginning any minute now. So as Dendra mentioned, I'm with Western Canada On-Site Wastewater Management Association. We're a not-for-profit industry association, and our main focus is training and certification in order to professionalize the on-site wastewater industry in Western Canada. So we've been doing this for over 20 years, probably as long as WasteWater Education.org has been doing their training programs. And another thing, of course, we do is we advocate for the industry, and we work with regulatory authorities to develop frameworks for on-site wastewater management so that we can ensure that we're protecting public health and the environment. So it's really important to understand that the water that we put into our on-site wastewater systems, whether it's a cesspool or what I would term, quote, a proper, unquote, system, sand mound, such as Ben was showing you, or any of a number of different technologies, eventually that water ends up back in the water table or in a surface water body somewhere, the ocean, a creek, a river, a stream, somewhere. And we need to ensure that it's properly treated before it gets to that point. So one of the sort of misunderstandings we've dealt with over the years are misconceptions about on-site wastewater systems. And they just demonstrate the importance of education and training. So there is a misconception in many quarters that wastewater systems are just piping and disposal. So as long as you can dig a pit or dig a trench and glue some pipe together, you're qualified to build a system like this. But unfortunately, that's not really the case. The bulk of treatment of effluent, which is the result of septage being settled out in a septic tank, the bulk of the treatment takes place in the soil. The microbiology in the soil is uniquely suited to help to consume the pathogens in effluent and treat the wastewater prior to it re-entering the water table. So people working in our industry need to understand how water moves through the soil and how effluent is treated in the soil. As I mentioned, we've been training for over 20 years, and we focus on site and soil analysis and building the right type of system for the site. So as Ben mentioned, there's a variety of different systems, and each site is unique in and of itself. So there are no cookie cutters, or there shouldn't be, for these types of systems. Each site needs to be assessed individually to determine what type of soil are we dealing with, how much soil do we have, and how well will this type of soil and this depth of soil treat the effluent that is coming out of our pre-treatment components, either our septic tank or a package treatment plant of some kind. So we assess site and soil the same way everywhere in the world, even though soils vary, of course, from region to region. And so understanding that and how to work effectively helps us to develop plans for systems that protect public health and the environment. So some of the challenges that we face, and I'm sure that are typical in Hawaii, we have challenges with footprint size, so small sites. I don't know whether you're experiencing this or not, but we're seeing more and more larger homes on small lots. We have challenging geography here in Canada. So even though we have prairies where you can dig all the way to Asia if you want to, we also have fractured rock and volcanic rock and things like that. So we have challenging geography that we have to address, just as Hawaii does. We have a lack of soil depth, particularly in British Columbia, and we have to address that. And we also have a lack of appropriate soils in certain areas. So we need effluent to be retained in the soil for a period of time long enough to ensure that treatment occurs. So when we have a lack of soil depth and very poor soils, then we have to increase our technology in order to address that so that we can again get the treatment that we need. We also deal with challenging weather conditions. It's not 40 degrees here like it is for Ben, but we have extreme heat in the summer and extreme cold in the winter. And in British Columbia, we have extreme precipitation. So all of those things impact the types of systems that we can design and install to provide that infrastructure that unsewered homes need. So we're always looking for innovative solutions, and I'm not going to go over every innovation that we have utilized over the years, but one of the more recent ones, and we're talking recent sort of in a decades type thing, are what we call LFH grades. And I'm going to speak to these specifically because I understand there are a number of, I think they're called Abesia trees, Dendra, correct me if I'm wrong, but that are sort of an introduced species and that are nuisances, and you have a lot of potential wood chips, and these types of systems utilize wood chips in their design and installation. So this is a system that was developed by industry, and it was developed for sites that were heavily treed or at least fairly well treed with poor soils and shallow soils. So sometimes less than 12 inches of soil or just at 12 inches. We researched this technology at the University of Alberta and University of Calgary, and found that we achieved really excellent treatment within a foot of the soil surface where the effluent was being applied. So I thought I would speak to that because I think it is a technology that might be an effective technology in Hawaii. So some of the things we need for a system like this is we need an LFH horizon. So LFH stands for litter, fermented, and humic. So basically it's the leaf litter and forest debris in a treed area. And these can be any kinds of trees. You know, they can be deciduous or coniferous areas, or, you know, whatever types of trees and plants are available. It's the microbiology in the LFH layer that's critical to the system. Slope sites are preferred actually for these types of systems, which is appropriate for the Hawaiian Islands, of course. And you do need some available space to put a system like this on. But how these systems work is they work with the natural topography on the site. So we don't have to excavate or trench or anything like that. Once we've assessed the type of soil we're dealing with and we know how much effluent we can load on that particular soil per day, we build a pressure distribution system, and we will actually wind it through the treed area. And the effluent is delivered through orifices that are drilled along the lateral lines here. These are distribution laterals, and they're pressurized so that when the pump comes on, they produce a certain volume of effluent that sprays out of the orifices. These are diffusers here that help to ensure that we don't point load, so that when the pump comes on, we're not drilling a hole basically from the high water pressure into the surrounding area, but that it spreads it out. So once we build our pressure system, we use these are called chambers, and they go over top, and they provide two sort of purposes here. They hold oxygen because they have a void space inside, and they also act as an upper orifice shield for the pressurized lateral lines. So we lay those out over top of our system, over our pressure system. And this is actually the delivery line, but I just wanted to demonstrate that this whole system is now then covered with wood chip. So what we do is we utilize the leaf litter layer to help disperse the effluent over a larger area. and to also the microbiology. The bugs in the leaf litter are very good at consuming pathogens, as are the bugs and bacteria in the soil, very helpful for treating wastewater. And so we cover this whole thing with wood chip, and after it's installed, you really can't even tell it's there. And over time, the natural forest activity in the forest takes over, and you'll get the undergrowth that normally occurs in a treed area and that kind of thing. And so the trees and vegetation typically uptake quite a bit of the effluent and nutrient. The wood chip provides a natural layer that we get good oxygen transfer through, which we need in our system to help encourage aerobic bugs, which are more efficient at effluent treatment than anaerobic bugs. And we utilize the wood chip cover to protect the system, insulate it from heat and cold, and to protect public health and safety. So it's a natural canopy that covers the entire system, and just breaks down over time. Over time, you would apply, like maybe every decade, or depending on what the breakdown rate is, you would apply perhaps another layer of wood chip as needed. But these systems work very well, and they are suitable for challenging sites, which I think you certainly have in your neck of the woods. So I'm just showing you. So one of the conclusions we found over the years are that there are technologies available to meet even the most challenging sites and situations, even situations where we lack decent soil, where we have small footprints, where we have large volumes of water. But the critical component is education. The industry needs to be educated on how to properly design and install those technologies. Regulators need to understand the importance of proper on-site wastewater design, and the general public needs to be aware of their impact on the environment and the importance of proper treatment and dispersal of wastewater. So before you can move to change what types of technologies are needed, so before you replace your cesspits, you're going to have to educate your public and your regulators, and you're going to need a trained industry, because if you don't have those three, the public will push back against the need to replace the systems. The regulators will not understand the importance of having proper systems that protect public health. They understand that we need to protect public health and safety, don't get me wrong, but there is a lack of understanding on how these systems function and where the water goes at the end of the day. And then once the industry is trained, we have those technologies. We have the technology. We can build a better robot. Is that it? I can't remember the quote, but anyway. So that's sort of my end of the industry, I guess, the end that I come from. And I'm going to pass it over to Richard from Ireland, Richard Flynn. I'm just going to stop my share here. Give me a second. I will do that.
Thank you, Leslie. Hello, everyone. It's coming up to 1 a.m. on Saturday morning here in Ireland. We're an island nation here also, and the western end of Europe. Richard Flynn is my name. I'm in private practice for the past 37 years. I'm a chartered engineer, chartered building engineer, chartered environmentalist. And my work really is site suitability assessment, wastewater treatment system design, dealing with problem systems, on-site wastewater treatment systems where there's no public sewers. In Ireland, we don't have a licensing system. site assessors, system designers, installers, maintenance personnel. No one is licensed. It is desirable as a site assessor to carry out specialist training, and there is a specialist training program, site suitability assessment for on-site wastewater treatment systems, which the majority of site assessors complete. We're relatively new in terms of legislation. We have an EPA Code of Practice 2021, which really came from a manual that was designed and produced in the year 2000, followed up with a Code of Practice in 2009. We finally got around to revising that and updating it, and we have our new code, which was produced in 2021, is current law. Problem sites is really what I deal with. The issues really is questionable site suitability assessment. Has the site been assessed properly? Poor quality wastewater treatment system design. You know, has the right design gone in? Has it been installed correctly? Has there been maintenance? Obviously, lack of maintenance is a serious problem. And again, there's no oversight of treatment systems. Once they go into the ground, that's it, they're forgotten about. As Ben said, one size doesn't fit all. So a lot of the solutions we come up with are site-specific solutions, following site suitability assessment, soil analysis, depth to water table, percolation tests. I'm just going to show you one particular design that we came up with. It was a design I came up with a colleague of mine, Phelim Harty, who specialises in reed bed and constructive wetland design. Phelim again is a consultant in private practice, and he has kindly offered to do a presentation, which hopefully we'll have in the next couple of months available, on his area of expertise. This particular site, an existing house on the shores of Loch Derg, very much a nutrient sensitive area. The important thing for us was not alone just to put in a good quality treatment system, but also to try and reduce the amount of nutrients being produced. So what we done is we produced a partially raised bed, again shallow limestone bedrock. We imported. We were lucky we could source suitable sandy gravel. It's not always possible. In some areas we actually use crushed glass. We do have one or two good suppliers of crushed glass. But this particular case, as you can see, we put in our partially raised percolation area polishing filter using low pressure distribution. And we planted willows on either side of the bed. So what happens is the willows are coppiced alternately every 4 years, cut back to the bone, and they reproduce, and you can see them there in full growth. It's a good solution. It's a practical solution, best practice solution, and results in an environmental gain, and also protects the nutrient sensitive area of Loch Derg. Again, it's probably something that could be used in Hawaii. It's a possibility. Again, I can share information on this in a lot more detail for anyone that wants it. We can share it offline, or we can share it on our website. So that's short and sweet. I'm not going to get into any more details. Thank you for your time. And just a reminder of our events coming up on 27th November and the 3rd to the 8th of December. Thank you.
Thank you, Richard.
Just I think I'm handing back to Dendra.
Yeah, thank you. We are really looking forward to that presentation about constructed wetland. I think that is it's going to be a very eye-opening, I think, event. Any questions from our friends in Hawaii?
So while we're waiting for more questions, sorry, go ahead.
Oh, there's one here that I've just seen. Is there a media that's good at removing PFAS? Some volcanic media have been used for that. there is an American company called ECT2, which has developed up an ion exchange media specifically for removing PFAS. It's got to be in a combination of in a treatment chain. It just won't work on its own. They typically have some form of oxidation with it as well, ozone or hydrogen peroxide. But yeah, there is beginning to be selective ion exchange media for removing PFAS from wastewater. So,
Ben, the thing I put in the chat was I saw a presentation for the states of Guernsey, and they're looking at removing PFAS as well. So they're having some success.
Yeah, I've got a couple of installations where we do our ozone work. We've put some into Air Force bases with a number of companies who are, it's one of those things prior to COVID, tracking viruses and COVID virus and untreated wastewater. PFAS removal's been the sexiest thing in water treatment for years. So there's a number of technologies. University of Alberta's been trying things, and yeah, all around the place, and everybody's ion exchange is a big one for it because it's a relatively low cost, low energy technique. So yeah, it's interesting, and I think it's a problem we're going to be dealing with for decades as far as treatment techniques and solutions. So
I was just over at the University of Alberta visiting their lab, and yes, they are actively researching PFAS removal at this time.
Yeah, it's kind of awe-inspiring how long this organization has been in existence, that we hosted one of the first online events looking at the original PFAS contamination from the Wolverine plant in Western Michigan. It's definitely the forever chemical.
Yeah.
But the point I'd like to make too, though, and I know we're coming to the end of our time here, is we've always had a basic premise that fits really well working in island nations or in island communities, and that is locally sourced material, locally sourced professions, locally sourced manufacturing. It's really important that when you are proposing a solution to a perceived and real problem, as we have here, which is 90,000+ systems that need to be replaced, is that the money that's going to be spent on this, whether it come from federal sources or state sources, should hopefully to a large extent stay here, that we propose options that support the local community, this local environment, and the local economy. Because, okay, we're replacing 95,000 cesspits with on-site systems. That means there is a lifetime opportunity for people to actually maintain, repair, replace, keep these systems going. This isn't a one-time fix that you take one thing out of a hole and put something else in there. As Leslie and everyone here has pointed out, this is a profession. You need to know what you're doing, and you need to have the skills to make sure that you're not replacing one environmental catastrophe with another one. So that's my closing 2 cents worth. Anyone else on the board have 2 cents they want to add in before we say thank you and aloha?
Well, just thanks for having us and listening. It's 90,000+ systems will be a challenge. But it is doable. That is, and as Dendra said, it will create ongoing employment for people to manage and maintain those systems once they're installed. somebody, what was the external cost to implement this system? Oh, I love the money. I love the money questions. Okay. So whenever I give a dollar value, people sort of marry themselves to that number, but there are all kinds of factors that impact costing. And one is access to materials, and of course, size of the system, which is dependent on the size of the residents being served or the facility being served, etc. But an LFH at-grade system, which is fairly labor intensive, in Alberta, you're looking at about $40,000. Now, granted, it's more expensive here than elsewhere, and if you have access to free wood chips, then the cost goes down significantly. It's less expensive in British Columbia. They have more trees, if you want to look at it that way. So probably $10,000 less there. It just really depends. But systems, different systems have different price points. Don't forget that's Canadian dollars too. So you would have to do the math on that. But different systems have different price points. So depending on the site, a simple gravity system can be relatively inexpensive, at least inexpensive in our world. You know, say a comparative of $22,000 as opposed to the 40,000. And as you kind of go up the sophistication scale, the price goes up. So, but, you know, we'd have to run the numbers for a Hawaiian scenario, which we can do, and we can provide that to Dendra to share with you. Because as I said at the beginning of my apology for the cost, it is dependent on access to materials, what native materials are available, and system size. So we could run some numbers based on average residence size, access to materials, and labor cost, and come up with an estimate, which would probably be better than basing it on what somebody in Canada would be looking at paying for a system like that. Dendra, you want to work with me on that?
Sure, I would like to.
There you go.
Okay. Yeah, it goes back to the comment I was making. It's that when you are supporting a change in technology, I think it's important that you do so in support of your local community. Anyone that lives in Hawaii knows that 9/10 of the cost is shipping. If you're replacing a system with something that has to be brought in from the mainland, then of course it's going to be more expensive. So any of the systems that we are proposing as demonstration or alternatives here are actively seeking out local manufacturers to support local construction and installation. Ben, would you like to have a quick word about that?
Yeah, there's a couple of new questions which have come through, but freight's a big thing. There's a bit of a volcanic ring around Australia type of thing, but a big cost of where we've been using our zeolite and working with it's just, you know, the cost of putting large amounts of rock onto a truck and driving it hundreds of miles is not cheap wherever you go in the world. So if you can get those local materials and local wood chips, if you can find a waste product, like where we're doing wood chip work like Leslie's talking about there, we go to our local governments where they've got green waste facilities where they put things through chips, where we have lots of what we call cyclones, you guys call hurricanes and typhoons come through with the power lines. The power line companies are always going through my part of Australia and cutting trees out of power lines. They're a fantastic source of wood chip. They're a waste product to them. They're a resource to us. So being able to get them and reuse them. The question here of the pressure systems, the Washington State Department of Health has got an absolutely very good code on how to design up a pressure system. So there are restrictions as far as the length of pipe that you can have and the types of pumps, as far as getting an even distribution across your pressure system. So there's definitely tricks to the trade. As far as that, some very old Greek mathematics, as far as the diameter of the holes that you drill on the top of the pipe, like what Leslie was talking about there, compared to the diameter of your pipe. So there are tricks and techniques that you use to get even distribution. And yeah, create facilities on location. Yeah, it depends on the technique that you're using, the original, as far as being able, what techniques that you need to do, and Dendra will be able to provide some additional stuff there. But yeah, being able to use local, anytime you can turn a waste product or an abundant, low cost local material into something you can use in your system, you'll reduce costs. And Leslie had an excellent example of that, where trees are much more abundant on the Pacific coast of Canada compared in further inland in prairie country in Alberta. The cost of the system varied by as much as a quarter, just due to the abundance of local materials. So yeah,
I'd like to comment with regard to a facility for on-site location. Typically our systems are built on site. They're not built in a factory or a facility, although the components may come from a factory. And another good source for the wood chip too, Ben, is arborists. Arborists have a ton of it as waste material. So you can quite often get that inexpensively. If you have to buy it, it's expensive. But if you don't have to buy it, it really can cut the cost.
Yeah.
We also have a pressure distribution manual and tables for calculating pressure and pump sizing and things like that. So those are available from Washington State, as Ben mentioned. We have them as well, and I'm sure other agencies also that build pressure systems also have them.
Okay, I think we've exhausted our time allotment. Would you like to wrap it up there?
Yeah, sure. Yeah, as we wrap up our today's seminar, I want to thank you everyone for joining us, our seminar series. And also I really appreciate our speakers from WasteWater to share their thoughts and knowledge. And just as a reminder, our upcoming seminar is scheduled for December 1st. Stay tuned for more details, and I look forward to seeing you or at the future events, and have a great weekend to everyone. Thank you.
Thank you.
Thank you.
thank you.
Yeah.